Okay, so now we are on to Unit 1.4, which is rational expressions. And so what we need to remember about rational expressions, so the word rational comes from rational numbers, which comes from ratios. So ratios is anything that can be written as a fraction. So a rational number is basically anything that can be written as a fraction. So like in B, would be a rational expression. This would too, because it's over 1. But we just call it a polynomial expression because it is just a straight up polynomial expression, right? There's no denominators or anything. So when we want to find the domain is what are the x values that I can put into an equation. So when we have a polynomial equation like we do in A, what x values can I plug in? Can I plug in 0? Yeah. Can I plug in 1? Yeah. Can I plug in -1? Yeah. Are there any restrictions as to what I can plug in? No, there aren't. So then the domain for a question like problem 1 would be all real numbers. So I could write that as all real. So that fancy little R there. I know that's something we did earlier in the year. But now for B, we have this rational expression. And so what we need to do, and this is why Unit 1.3 was really important, what we need to do is we need to say what makes a fraction undefined. What explodes a fraction? It explodes when you have the denominator equal 0. And how am I going to know when the denominator equals 0? Well, right now I don't know, but what I do know is that what I can do is I can factor this, right? Are there factors of 6 that add up to -5? Yeah, sure. It could be written as x minus 3 times x plus 2. And I know that I want this to not equal 0. So what I'm going to say is this can't equal 0. And let me just solve it so that I know what the denominator can't be equal to. So I know that x minus 3 can't equal 0. And I know that this should be a minus, shouldn't it? Yeah, I screwed up. X minus 2 can't equal 0. So then I know from this that if I add 3 to both sides, I get x can't equal 3. And if I add 2 to both sides, I know that x can't equal 2. So my domain will be, there's a couple different ways to write this. For now, we'll just write x can't equal 3 and x can't equal 2. For now, we'll just write it like that. We're going to learn a couple different ways to write it later on. So now, on to example C. Oh, you're going to say, oh, look at this. This looks so easy. I can just say this can't equal 0. So I know that x can't equal 5. And you're right, x can't equal 5, but there's more domain restrictions to this than what meets the eye. I know, can I plug in whatever I want into square root of x and it will get me out an answer? No, there are things I can't plug in, right? Can I plug in 1? Yeah. Can I plug in 0? Yes. But can I plug in -1? No, I can't, because remember, the square root of -1 is an imaginary number. And right now we're talking about real numbers. And so I can't plug in a negative number. So I know that from the top, x has to be greater than or equal to 0. So those are my two domain restrictions. And for now, we'll leave it like this. In chapter 1.5, I think, we're going to learn some notation as to how we could write this a little bit better. So now on to example 2. Example 2 is here. And now I just want to simplify this rational expression. Okay? So what I need to do in order to simplify this rational expression, well, the first thing I need to do is figure out what are my domain restrictions for this. So there's no domain restrictions from the top, and the domain restrictions from the bottom, well, I'm going to have to factor it to find them out. So let's just factor it. So I know that my factors of -2 that add up to +1, right? There's a little imaginary 1 there. So I know my factors are x minus 2 times x, oh, that's a +2, x plus 2, x minus 1. So I know that my domain restrictions tell me x can't equal -2, x can't equal 1. So those are my domain restrictions. And I'm going to need those later because when I simplify, maybe one of those will cancel out and I won't know that it exists. But it still exists even if it cancels out. And so now I need to factor out the top. So if I factor the top, this is the difference of two squares, right? So I could rewrite that as x plus 1 times x minus 1. And now look, I have a factor of x minus 1 on the top and a factor of x minus 1 on the bottom. And now this is when I can start canceling things out, when I have factors of them. So what I can do is I can just cancel out this and cancel out that. And so my final expression will be that x plus 1 over x plus 2. Okay, and I have to wait till I get it into this factored form to start canceling, because think about it like this. If I had let's just talk for a second. This is kind of a tangent, but I think it's very important. If I had something like this, if I had x plus 5 over 3x plus 5, I can't just go, oh, look, I have these plus 5s, and just get rid of them, right? That's illegal, because think about it like this. That would be like saying 7 over 4. Well, 7 is really 3 plus 4 over 4, so I can just cancel that out and say that it's 3. And we all know that 7 divided by 4 isn't 3, right? So I can't factor it out when it's added. I have to wait till it's factored, like it is here. Okay, so sorry about that tangent, but I think that tangent pretty important. So now, let's look at example 3. So now I'm multiplying two rational expressions together. And if we remember how we multiply our fractions, if I had something like 1/2 times 2/3, what I would do is I would just multiply straight across. So I do 1 times 2, that equals 2, over 2 times 3, that equals 6. Right, so we just multiply straight across. We don't do cross multiplication or flip the fractions or anything like that. We just multiply straight across. And I'm just hammering that home because people forget what to do when we multiply fractions. So the best way to do this is, well, I could multiply this all and get some really super complicated thing. Or I can factor this out and see if there's anything I can cancel. So that's what I want to do first. So I'm just going to start factoring this. So I'm going to pause and I'm going to factor. You can pause, you can factor, and we'll come back together when it's all factored. Okay, so now I have it all factored, you have it all factored, and we can see that before I even do anything, there's stuff I can start canceling out. I have an x minus 1 on the top, and I have an x minus 1 on the bottom, so I'm going to cancel those out. I have an x plus 4 on the top, and I have an x plus 4 on the bottom. So almost everything cancels out. So my final answer that I'm going to be left with is I have a 3 on the top, and I have an x plus 3. Over, the only thing I have left on the bottom is an x plus 4. So that's my final answer, 3 times x plus 3 over x plus 4. And then lastly, we're going to do example 4, where we have some division, some rational expression division. Okay, and it's going to be the same thing. So if we remember how to divide, if we had that same 1/2 divided by 2/3. So when we have division of fractions, we do keep, change, flip. So that's really going to be equal to 1/2, and then I'm going to change it to multiplication times, and then I'm going to flip the fraction, 3 over 2. So it's going to be equal to 3 over 4. So that's just one of those things we have to remember about how to do. Okay, and so now we have this problem, and so all we need to do is factor it. So let's take a minute. I'm going to pause, and we can factor it. Okay, so what I did is I factored it, and then I did my keep, change, flip. So now I have this expression, and I can simplify. So I have an x minus 4 on the top, and x minus 4 on the bottom, an x plus 2 on the top, and x plus 2 on the bottom. And I can cancel that out. And so on the top, I'm just left with Let's just write it somewhere else so that I have more space. I'm left with x plus 3 over x minus 2 times x plus 1. And that will be my final answer. Okay, so now if we look at example 5. Example 5 is adding these. And adding is when we start to remember we have to do common denominators. So common denominators mean I need to find the same thing that goes onto both. So the easiest thing to do is, well, I have x minus 1 over here, and I have x plus 2 over here. So my common denominator is going to be x minus 1 times x plus 2. So I'll just take this side and multiply it by x minus 1 over x minus 1. I'll take this side, I didn't leave myself much room, and write x plus 2 over x plus 2. So then I'll just do the multiplication out, and I have 3 times x plus 2, so I get 3x plus 6 over, and I'm not going to do the multiplication out on the bottom, x plus 2 times x minus 1. Well, I'll do it out later. Plus, and now I'm going to do this multiplication out, x squared minus x over x plus 2 times x minus 1. Now I'll add the top. So if I add the top here, so I have just adding polynomials like we did in the last section. So I have x squared plus 3x minus x is plus 2x, and then plus 6 over my denominator, x plus 2 times x minus 1. And so the reason I didn't multiply this out yet, the denominator, is because maybe I can factor this numerator and cancel something out. So let's look. Are there factors of 6 that add up to positive 2? There aren't. So I'm stuck there. So I can't cancel anything out. So I may as well multiply out my denominator now. So my final answer is going to be x squared plus 2x plus 6 over, and then if I multiply this out, I get x squared minus 1x plus 2x is minus 1x, and then minus 2. And that'll be my final answer for that one. And now onto the second one, onto example 5b here. So I have a subtraction problem now. So once again, I need common denominators for subtraction. So what I'm going to do is I'm going to factor out the bottoms, the denominators, and see what I get. So I get this is x minus 1 times x plus 1. And this is x plus 1 times x plus 1. So I need to have an x minus 1 and 2 x plus 1s as my denominator. So I know that I already have 1 x plus 1 in this one, so I'm going to multiply it by 1 x plus 1 over x plus 1. And here I have my x plus 1s, but I need an x minus 1, so I'm going to multiply it by an x minus 1 over x minus 1. So if I do out this multiplication, I'll get x plus 1 over x minus 1 times x plus 1 times x plus 1 minus, if I do out this multiplication, I'll get 2x minus 2 over x plus 1, x plus 1, x minus 1. And so I'm leaving the denominator unmultiplied out for now in hopes that I can cancel. I don't know if I'll be able to or not. But we will pick up this problem at the beginning of the next video because I am out of time.